Welcome back, all my aspiring mathematicians and my number shrinkers. In the world today, we often use words and numbers every day. Believe it or not, yes, we do. Now, when we are reading words. When we are speaking words. When we things, we are working with numbers. Even if we go out there and we are not buying anything, but we are getting on the subway, or we are taking the train or the plane or the bus, it has to do with numbers. Not only that, just walking alone has to do with numbers. Every step you're taking, when you add them up, has to do with numbers. It's all about numbers. Whether you love numbers or not, or you love words more than numbers, it's fine. But we all have to use both in our everyday life. I love to shrink numbers, and that is actually one of my many passions. Now let's analyze the numbers between 1 and 10. So the numbers between 1 and 10 are 2, 3, 4, 5, 6, 7, 8, and 9. Now there is something unique about these numbers. When you multiply these numbers, and if you don't get a single digit, you can add those digits that you get once they're not a single digit, and then come to one single digit. And we will do this for each of these numbers, starting with 2, then we're going to do it with 3, 4, 5, 6, 7, 8, and 9. And we are going to discover something unique about 3 of these numbers, and something even much more unique when it comes to one of those numbers. So let's start with the multiplication using the number 2, and I'm going to just simply do it all the way down to 20 for each of these numbers, and then we are going to analyze this and put it together. So let's get started. So we have the number 2. If I do 2 times 1, I'm going to get 2. 2 times 2, I'm going to get 4. 2 times 3 is going to be 6. 2 times 4 is going to be 8. 2 times 5 is going to be 10. 2 times 6 is going to be 12. Now you'll notice we no longer have single digit here, so I'm going to do a column where I'm going to add. Alright, so I'm going to add my double digits to get one digit. Take my number 10 that I get here, and I add 1 to 0, I'm going to get 1. If I add 1 to 2, I'm going to get 3. Okay, so I'm going to continue down. 2 times 7 is 14. I'm going to add my 1 with my 4. I'm going to get 5. 2 times 8 is going to be 16. I'm going to add this. I'm going to get 7. 2 times 9 is going to be 18. I'm going to add this, and I will get 9. And then 2 times 10 is going to be 20. Add this, I'm going to get 2. And then 2 times 11 is 22. I'm going to add those digits. I'm going to get 4. And 2 times 12 is going to be 24. I'm going to add these digits. I'm going to get 6. And 2 times 13 is going to be 26. And when I add those, I'm going to get 8. 2 times 14 is going to be 28. And I'm going to put my column here where I'm going to add these. I'm going to get 2 plus 8 is going to give me 10, and then when I add that 10, 1 plus 0 is going to be 1. Alright, so 2 times 14 is 28 there. Then if I do 2 times 15, I'm going to get 30. When I add that, I'm going to get 3, and then 2 times 16 is going to be 32. When I add this, I'm going to get 5. 2 times 17 is 34. When I add this, it's going to be 7, and 2 times 18 is going to be 36. When I add that, that is going to give me 9. 2 times 19 is going to give me 38. When I add these, I'm going to get 11, but when I further add 11, I'm going to get 2. Alright, so I should have actually did this one for here, which is going to give me 1. Show you that. So 2 times 20 is going to give me 40. So when I add this, to get 4 here. You will notice a pattern here. So when you started first with multiplying 2, you end up with single digits first for the first 4 numbers, and then when you look at these single digits, you notice that they are even numbers. But then, yes, all the other numbers are going to be even numbers, right? But I told you, you need to get just simple one number here, single digit. So because we had 10, 12, we had to add those, and 10, which is simply adding the 1 to the 0, is going to give you 1. You will notice when you do that coming down, you end up with odd numbers up to 9. Notice the even number does not pass. You don't want a double digit, so that's why you have to stop here at 8. For the odd number, you stop at 9. And then when you start over again, it's starting all over with even numbers. And then it starts again once you get to 8. Then you have your odd numbers again. And then you're going to continue down having your even numbers. If you continue with even further beyond your 20, if you do 2 times 22, you're going to get 44. This is going to give you simply 8. But you notice here that even though you have the 8 here, right, you will notice that the next number you are going to get, because you have 2 times 23, which is going to be your 46, then you're going to add these, it's going to be 10, and then when you add this, it's going to be 1, and you're starting all over again. Now you're going to do this continuously, right, all the way down, and you will see that when you get to one number, you're going to have a pattern there. Let's take this further and let's multiply the number 3. And then when we multiply the number 3, we are going to see what we are going to get when we add any double digit, or any, even if we get a triple digit number, we are going to add that and get 1 digit. So let's start out with 3. So 3 times 1 we know is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. And we notice that we're moving from single digits now to double digits. So where we have 3 times 4, which is 12, you notice you're now going to have 1 plus 2 is going to be 3. And then 3 times 5 is going to be 15. So 1 plus 5 is going to be 6. 3 times 6 is going to be 18. And the 1 plus 8 is going to be 9. There is a pattern here. If you continue down, 3 times 7 is 21. When you add the 2 and the 1, you're going to get 3. When you do 3 times 8, which is 24, you add the 2 and the 4, you're going to get 6. When you do 3 times 9, you're going to get 27. When you add the 2 and the 7, you're going to get 9. If you continue, you will notice that 3 times 10 is going to be 30, and 3 plus 0 is going to be 3. So the pattern is repeating. The pattern here is that it's 3, 6, 9. So those numbers are divisible by 3, or you can say they are going up in increments of 3s. Alright, so that is for the 3 times table. Let's multiply the number 4 and see what happens. So for the number 4, you have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16. So for the 4 times table, you notice that for the first 2 numbers there, you have the 4 and the 8, that's fine. And then you will notice that you have double digits, and when you add the 12, you have 1 plus 2, which is 3, and then the 16, which is 1 plus 6, is going to be 7. And for the 20, you're going to, 4 times 5, which is 20, you're going to add a 2 plus a 0, which is 2. You will see a pattern there also, but the pattern is not as what you would see when you were doing the odd numbers. So for the number 4, the pattern is that you have 2 even numbers, which is a 4 and the 8, followed by 2 odd numbers, which is the 3 and the 7. Then you have 2 even numbers, which are 2 and 6, followed by 2 odd numbers, which are 1 and 5. And then you have 9, which Yes, the 9 is divisible there by 3, and then it repeats. Now let's move on to the number 5. The number 5 is a nice number because you know each number at the end is going to either have a 5 or it's going to have a 0 as the last digit. So let's start out with multiplying the number 5 and then let's see what happens. So 5 times 1 is 5. 5 times 2 is 10. Now we're getting to the double digits, so we're going to add that 1 to 0, we're going to get 1. Then 5 times 3 is 15, and then we're going to add that 1 to the 5 and we're going to get 6. Now 5 times 4 is going to be 20, and we add that 2 and 0, we're going to get 2. The 5 have a pattern where the first two numbers are odd numbers, meaning that you have 5 and the number 1, and then that is followed by two even numbers, which are 6 and 2. Then that is being followed by two odd numbers, which are 7 and 3, and then you notice you will have two even numbers, which are 8 and 4. And then you have the number 9, which is divisible by 3, and then you repeat the pattern again. Now let's go to the number 6. So for the number 6, when you multiply 6, which we are going to do this, and then when we get the single digit number is fine, but when we start getting double digit numbers or triple digit numbers, we need to add those digits to get just one digit. So we are going to start off with 6 times 1 we know is 6. 6 times 2 is 12. We notice here we have a double digit, so we are going to pause here and we're going to add the 12, which is 1, and 2, which is going to be 3. Then we know that 6 times 3 is 18, so 1 plus the 8 is going to give you 9. 6 times 4 is 24. When you add that double digit number, you're going to get 6. 6 times 5 is 30. When you add that, you're going to get 3. 6 times 6 is 36, and when you add those two digits, you're going to get 9. And this is going to repeat as you go along, as you can see right here. So you will notice that there is a pattern. The pattern is 6, 3, 9, and then it repeats again. 6, 3, 9, repeat. 6, 3, 9, repeat. And that is for the number 6. So let's move on to the number 7. 7 times 1 is 7. 7 times 2 is 14. So now we have a double digit number. So we're going to add the 1 plus 4, which is going to be 5. 7 times 3 is 21. We're going to add that 2 plus 1, which is going to be 3. And 7 times 4 is 28. We're going to add the 2 and the 8, and that is going to be 10. We're still going to add the 1 and the 0 to get a single digit, and that is going to be 1. So the pattern for the number 7 is as follows. You will get 4 odd numbers, which are 7, 5, 3, and 1. And notice these are odd numbers in decreasing order. Notice you don't have a 9 yet, right? So 7, 5, 3, 1, these are odd numbers, or if you want to say these are also prime numbers, that's fine. And they are in decreasing order. And then you're going to get 4 even numbers also in decreasing order. You notice you get 8, 6, 4, and 2. And then you're going to get the number 9. And 9 again is divisible by 3, right? And then the pattern repeats. So this is another thing that you'll notice here with the pattern. So that is for the number 7. Let's move on to the number 8. Let's multiply the number 8. 8 times 1 is 8. And then 8 times 2 is 16. And then we are going to add the 1 plus 6, which is 7. 8 times 3 is 24. We're going to add the 2 plus 4, which is going to be 6. And then 8 times 4 is going to be 32. We're going to add the 3 plus 2, which is going to be 5. And 8 times 5 is going to be 40. And we're going to add the 4 and the 0, we're going to get you 4. 8 times 6 is 48. And we're going to add the 4 and the 8 to get 12. Another double digit number. So we're going to add again the 1 and the 2. We're going to get 3. And then if we do 8 times 7 is 56. So we are going to add the 5 and the 6. So we're going to get 11. And we also have to add the 1 plus the 1 from the 11. And we are going to get 2. we will continue by doing 8 times 8, which is 64, and when you add that, you're going to get 10, which is still a double digit number, and we are going to simply make it one digit number, which is going to be 1. There is also a pattern there. So the pattern is that it starts with the number 8, then it starts descending, going from 8, 7, 6, 5, 4, 3, 2, 1. And then you're going to see 9 occur when you do 8 times 9, which is 72. When you add 7 plus 2, you're going to get 9 right there. And if you continue, you will notice that 8 times 10 is going to be 80. And when you add the 8 and the 0, you're going to get 8. 8 times 11 is going to be 88. When you add those, 8 plus 8, you're going to get 16. And when you add the 16 again, meaning the 1 plus 6, you're going to get 7. So once again, starting with the number 8, it's going to decrease to the number 1. And then you're going to have the number 9. And then it start decreasing once again. So that is the pattern for the number 8. So now, let's get into the last number, which is between numbers 1 and 10, which is the number 9. Let's start out with the number 9 and multiply those and see what happens when we get a number that is a double digit, and when we add those two digits, what number we are going to get. 9 times 1 is 9. 9 times 2 is 18. You have a double digit number here, so you are going to add 1 plus 8, which is 9. So let's move on. 9 times 3 is going to be 27. You'll notice here that you have that 27, and you are going to add the 2 plus 7, you're going to get 9. We are going to continue and do 9 times 4, which is 36. When we add the 3 and the 6, we are going to get 9. 9 times 5 is 45. When we add the 4 plus 5, we're still going to get 9. Let's do 9 times 6. It's 54. 5 plus 4 is 9. Let's move on to 9 times 7, 63. Let's add the 6 plus 3, 9. Let's do 9 times 8, 72. Let's add those two numbers. We're going to get 9. Let's do 9 times 9, 81. Let's add those numbers. We are going to get 9. Let's do 9 times 10 is 90. 9 plus 0 is 9. Let's look at 9 times 11, 99. 99, 9 plus 9 is 18. Still have a double digit, so let's continue to get a single digit. And so we're going to add that 1 plus 8 is 9. Let's move on to 9 times 12. 9 times 12 is 108. You will notice there, you add the 1 plus the 0, which is 1, plus the 8, which is 9. You get 9. And you will continue doing this, and you notice every number here, when added for the multiplication of 9, is going to give you a single digit number, which is 9, which is itself, right? So you notice there's something unique about the number 9. It is very, very unique. It is also divisible by 3. It is divisible by itself 9. All right? So let's compare the numbers 3, 6, and 9, because notice the only numbers that had like 3 or a 6 or a 9 was the number 3 and 6 when we had multiplied those to achieve that single digit. And then the number 9 is it gets simply 9 throughout, no matter what you do. So let's get into this with something else. If I look at the number 3, and I'm going to do 3 to the second power, is going to simply give me 9. If I do 3, because some people are going to make a mistake and not knowing that the 2 is an exponent and may want to say, oh, 3 times 2 3 times 2 is definitely going to be 6. Okay? So 3 to the second power here is 9, right? Because you're multiplying 3 2 times and you're going to get 9. 3 to the third power is 27. If you add this, you're still going to get the number 9. If you continue and then do 3 to the fourth power, which is the 27 here, by 3, you are going to get 81. When you add this, it's going to give you the number 9. So you notice that there when you're doing the exponent there. Let's look at the number 6. Have 6 to the second power is going to be 36. When you add these, you are going to get, when you add these two digits, you're going to get 9. Let's do 6 to the third power, right? 6 to the third power. So you have 6 times 6 is 36, 6 is 18, 216 here. When you add these, you're going to get 3. 3 plus 6 is going to be 9. 6 raised to the fourth power is going to give you 1296. When you add those digits, you're still going to get the number 9. When you do 6 to the fifth power, you're going to get 77, 76. Add those digits, you're going to get 9. So let's analyze this. So the number 3 raised to any exponent except 1 is going to give you the number 9 if it is a single digit. If it is not a single digit, you're going to add those digits and you're going to get 9 as your single digit. 6 to any exponent except 1 is going to give you 9 when you add all those double digits or triple digits or quadruple digits. You're going to come down to one number, which is 9. So let's also analyze and look at what will happen when we have the number 9 raised to any exponent. So we have the number 9 here, 9 to the second power, and even if we do 9 to the first power, we're going to get 9. This is going to give us 81, and when we add that, we are going to get 9 there. 9 to the third power, right, is going to give us 729, and when we add these, we're going to get 9 here. 9 plus 9 is going to be 18, and 1 plus 8 is going to be 9. And you continue down the line, when you have 9 to the fourth power, you will notice that you will have 65, 61. When you add those numbers, you're going to get the number 9. And you will continue down the line all the way down. Only difference here, for the exponent raised to the first power, like 9 to the first power, then you will get 9. But for 3 and 6, you're not going to get that 9 when you raise 3 to the first power. You will get 3, and then 6 to the first power is going to simply be 6. Also, you have 3, 6, and 9. This is also a pattern. 3, 6, 9. 3 plus 3 is 6, and 6 plus 3 is 9. You notice that the number 9 is divisible by 3. The number 6 is divisible by 3. And 2, the number 3 is divisible by 3. So the numbers 3, 6, and 9 are unique, but the most unique number is the number 9. In math, we always can talk about divisibility, and we can talk about numbers that when you multiply them, and odd numbers we can talk about also prime numbers. We can look into even numbers and things of that nature, raising a number to the exponent, and we can analyze numbers in general. In conclusion, in the world of mathematics and when it comes to numbers, you will notice that there is a unique pattern that occurs, and also there is a unique situation that is occurring with the numbers 3, 6, and 9. They are precious numbers in my eyesight. I love the number 9, and the number 9, 3, and 6, they are all divisible by 3. If you notice, you can add 3 plus 3 is equals to 6, and also 6 plus 3 is equals to 9. They are all divisible by 3, and you can literally analyze these numbers and you will see this is unique about the number 9. So only the number 9, when you multiply it, and then after you get the first digit, which is 9, but the next digits after the number 9, when you add them together, you are going to get a single digit, and that single digit is still going to be the number 9. So there is something unique about the number 9. In terms of the number 3 and 6, you notice that there is a repeating pattern of 3, 6, 9 for the numbers 3 for the multiplication, and then for number 6 in terms of its multiplication, the repeating numbers are 6, 3, and 9. It's almost like the reverse. So you have there that uniqueness going on with these numbers, and only in the world of multiplying the numbers between 1 and 10, and then when you multiply those numbers, you are going to add any double digit or triple digit number that you're going to get to arrive at one number. So that is what I have to bring to you today on analyzing numbers, because I love math. Math makes me dance. Yes, I love to dance. I love to sing, even though I can't sing to save my life, but I know songs. Numbers are needed throughout life. We use numbers every day, and we use words every day. If you love words more than numbers, still try to embrace numbers, because you are going to use it every day in your life, no matter what, whether you're out buying things or even if you go for a walk. So it is a good thing to embrace numbers. And for all of you folks that love numbers like me, I hope that you will embrace words and enhance your vocabulary and use them every day. Don't forget, numbers and words goes hand in hand. You cannot live without one another. Embrace them. And there are people out there who love numbers as much as they love words. So that means they are very fluent in math, and they are also very fluent in English. And for those of you who have a little bit of phobia, I'm going to give you a little hint. Whatever you have a little bit of phobia in, try to practice more on that subject area or whatever it is, say 15 or 20 minutes per day, to help you to get over your phobia. It works. I always tell my students, try that. Okay? With that being said, I hope that you have already subscribed to my channel. And if you have not yet subscribed, what are you waiting for? Go ahead, hit that subscribe button. And guess what? Don't leave this information to yourself. Share it with others around the world. I'm sure there are math geniuses out there who love to deduce numbers, like myself, or analyze numbers if you want to use that word, so that they can learn. Or there may be some students out there or some children out there who have a quest for math. Don't hinder them. Share this so they can learn a thing or two. And guess what? Don't forget, hit that like button and leave me a comment. I like to read your comments and know what you're thinking. Thank you for watching. See you soon. Bye now.